Hey everyone, welcome to the lecture for 8.2. So in this lecture, it's going to feel really similar to what we did in 8.1, except we have the small change that we no longer are given the population standard deviation. So why? Well, we're not typically given a population standard deviation. In fact, what would be more reasonable is to expect to know really nothing about your population other than what information you have from the sample or samples. So what we're going to do here is we are going to change from a normal distribution to compute our confidence interval to a student's t distribution. They're really, really, really similar. In fact, when the sample size is large enough, say around 30, the student's t distribution and the normal distribution are, to the naked eye, indistinguishable. So when we do not have the population standard deviation, the calculation of the sample standard deviation S results in the sum of deviations equaling to 0. So this is something you can investigate on your own if you like, but this is the rationale for it. And if we have a sample of size n, then the degrees of freedom is 1 less than n. And degrees of freedom is a number that we need in order to compute the t value. So remember previously we had to compute a z value or a critical z value, or some people, a z score, that thing z alpha over 2. We still need that, but we're using it with a t distribution. So it's going to be called t alpha over 2. And for the student's t distribution, we need to know degrees of freedom. The degrees of freedom is simply 1 less than the sample size. So let's just kind of compare what we're doing here. So we're drawing a random sample of size n from a population. And we want to be able to, from that sample, say we're 95% confident that the population mean mu is between these two values. So I've listed some properties of the t distribution, if you care to read over those. Maybe more just for general interest. You don't need to know them necessarily to do these problems. So let's kind of just directly compare what we did in 8.1 to what we will now do. So in 8.1, we were given the population standard deviation. We computed the sample mean x bar from the sample data. Now in some problems, this was given to us, and some problems, actually it was always given to us. Now in the t distribution, it may be the case that they give us x bar, our point estimate, our sample mean, and it may also be the case that they give us a set of raw data and we have to compute the sample mean, but we know how to do that. Then the next thing we did is we found our critical value. So when the standard deviation is known as an 8.1, we use a z-score, right? So we have our confidence level. From our confidence level, we determine what alpha is. It's 1 minus the confidence level. And then we split that into 2 so that we get the 2 tails, right? And then the middle chunk is, for 95% confidence level, the middle chunk is 0.95 area. We're going to do the exact same thing with the t distribution. So again, the t distribution is when we do not have the population standard deviation. We're still going to have to figure out what our alpha is from our confidence level. That's the same. And rather than computing a z-score, we're going to compute a t-score. The way that we compute the error bound is the same in both cases. When we know the standard deviation as an 8.1, we're going to take our z-score times our standard error, which was the population standard deviation divided by the square root of n, where n was the sample size. When we don't know the standard deviation, we're going to take our margin of error to be the t value, the critical t value, or the t-score, and we're going to multiply it by our standard error. But in this case, our standard error is the sample standard deviation divided by the square root of n. And then from here, we're going to construct the confidence interval in the exact same way. So we start with our point estimate, and then we subtract the margin of error to get our lower bound, and we add the margin of error to get our upper bound, right? So nothing has changed. And as far as interpretation, how we set that up, nothing has changed either. So the takeaway here is that the only thing that's really different is in 8.1, we're given the population standard deviation, sigma, and we use a z-score. When we're not given the population standard deviation, we find the sample standard deviation and we use a t-score. So let's go ahead and do an example. So in Excel, we have a tab for 8.2. And the first question at the top of the left of the screen says, for a confidence level of 90% with a sample size of 22, find the critical t-value. So here we just want to go ahead and remembering that green is where we want to input values or data. We're given a confidence level of 90%. So that's going to be 0.90. We're given a sample size of 22. And we want to find the critical value. So if I wanted to compute a confidence interval, I need to have my point estimate and I need to have my sample standard deviation. To compute a t-value or a t-score, all I need is my confidence level and my sample size. So the t-score here, it's telling me that it's 1.7207429. So what I would do in this case is I would screenshot my data, insert it into my workspace, and maybe just kind of highlight my answer. All right, in the next case, they're asking us to find the margin of error. So in order to find the margin of error, because the margin of error is computed by taking our t-score or our critical t-value and multiplying it by the standard error, I need to know the standard error. Well, the standard error requires a value for the sample standard deviation. So notice that in this question, they give us that. So if n equals 21, so I'm going to put 21 as my sample size. They give us X bar. We actually don't need X bar because that's only used to construct the confidence interval and it doesn't affect the margin of error or the standard error. So we have to plug in S equals 9. That's our sample standard deviation. And then our confidence level is 0.95. And so from there, the margin of error, that's our EBM, error bound of the mean. And so our margin of error we see is 4.096. In the next example, we're given a survey. 20 people were asked how much they spent on their child's birthday gift. The results were roughly bell-shaped with a mean of $48 and a standard deviation of 10. Find the margin of error at an 80% confidence level. So our point estimate, that's going to be our mean, 48. Our sample standard deviation is going to be 10. This is the standard deviation of the 20 people surveyed. Our confidence level is 80%, so I type in 0.80. And our sample size is 20. And they are asking us again to find the margin of error. So this is looking at the same output, I think. So So your margin of error is here. All right, so next we're going to be looking at computing actual confidence intervals. So in this question, we have a survey of 14 people, so that's our sample size. Again, a child's last birthday, fine. The results were roughly bell-shaped. We have a mean of 50 and a standard deviation of 18. And our confidence level is 98%, so that's 0.98. And then what we do here is we see that this is our output. It's asking us for a format that we don't necessarily have here. Although it is there, it's just kind of hidden, it's not so overt. They're asking us for something plus or minus something. So this is actually going to be your point estimate, X bar, which was 50. And then this is going to be your error bound for the mean, or your margin of error, which was this number here. So that's what they're asking you to put in. All right, and this is kind of going backwards. Here they're giving us a confidence interval, and they're asking us to write it as we just did in the previous example, where it's the point estimate plus or minus the margin of error. So ME is another way of just saying margin of error, which we also refer to as the error bound for the mean. So in this case, we want to appeal to this lower table. It says compute the EBM and point estimate from CI, a confidence interval. So we put our lower value here, 472.4, and then we're going to put in 667 for our upper. And what it does is it gives us our point estimate, and it gives us our error bound for the mean. So what I would put in for my answer here is I would put my point estimate here, and then I'm going to do plus or minus my error bound for the mean, or my margin of error. In some instances, we won't be given the point estimate X bar nor the sample standard deviation S. Instead, we'll be given just raw data. So when we're given raw data, we have to compute our point estimate and our sample standard deviation. So here we're given some raw data, and we need to compute all that. So there is a space for you in Excel to enter your data up to 100 values, and it will compute your sample size, your sample standard deviation, and your point estimate for you. So the first thing you're going to want to do is you want to input your data into this region here where it says enter your data. So now that we have our data entered, we can see that it's computed the point estimate for us, the sample standard deviation, and the sample size. So all we need to do now is just transfer those values into our confidence interval builder. So X bar was 127.45. S was given as 25.9645001. And our sample size was 20. So now we need to figure out what our confidence level is. And it tells us in the problem at the very bottom, it says use this sample data to construct a 90% confidence interval for the mean number of targeted industrial chemicals to be found in an infant's blood. So my takeaway from that is 0.90. Okay, voila. So now we have our confidence interval. that is given to us here at the bottom. All right, this next example actually belongs in 8.1. So apologies. All right, so here we have some more cases where we're just given some raw data. So the Kyoto Protocol was signed in 1997 and required countries to start reducing their carbon emissions. The protocol became enforceable in February of 2005. This example contains random samples of CO2 emissions in 2010, and we want to compute a 99% confidence interval to estimate the mean CO2 emission in 2010. So the first thing I need to do is I need to enter my data into my table in Excel. So now that I have my data entered, I need to transfer my point estimate that was computed for me below to the top. So 3.4548. I need to transfer my sample standard deviation S. So that was 2.968. I need my sample size, and I also need my confidence level. So my confidence level they're asking for here is 99%, so 0.99. So now that I've done that, I can look at my confidence interval. So my confidence interval is given